Good day everyone, I'm Dan and I like to make props. And in this video, I'm going to show you how I turned this plastic 3D printed steel dagger from Skyrim into an actual metal dagger. But first, I have to print the dagger. After several minutes of research trying to find the most accurate model, I found myself on the Cult's 3D homepage where I typed in exactly what I was searching for, and not long after discovered this model from the STL Smith, which was perfect. Link in the description. I loaded up Mesh Mixer and imported the file to be cut up into more manageable pieces. I wanted to test which orientation would print the details most accurately. I first chopped the model in half so that it would fit on my print bed, then a second time, first along the Y-axis, export, Ctrl-Z, then again along the Z-axis for the second test. I sent both test models to Ultimaker Cura to write the G-code for my printer, using these print settings, and then printed them. Comparing the two test prints, I decided that the tool test's details came out much nicer than the flat test. So I cut the full dagger into 8 pieces and began printing. Here are the 8 pieces printed and ready to be assembled. I first sanded the contact points to make the join as seamless as possible. And then superglued 2 corresponding pieces, using some masking tape to hold them together. By the end, I had 2 flat halves of the dagger that I would need to keep separate for now, and you'll see why later on. Looking at the dagger close up, there were still large gaps between joins. So to solve that, I used a heap of spot putty to fill the imperfections, while also trying to avoid spoiling the details. I left the putty to solidify overnight and came back the next day to sand it smooth. The purpose of me putting in so much work now is because every imperfection left at this stage would show up on the metal version, and metal would be much harder to fix. Now it's mould making time. To make this sketchily built box, I cut up some wood, enough to make 2 identical frames with 4 sides.
Achoo.
Drilled some metal brackets in each corner. Measured out the dimensions of the frame. And crudely cut out the top and bottom. Using some Johnson's baby powder, not sponsored, I sprinkled a fair amount all over the inside of the frame. This will make separating the dagger from the mould as smooth as a baby's. You get the idea. Speaking of blowing, if you're enjoying this sort of content and want more, then leave a like and subscribe. The sand that I shall be using to make the mould is called Petrobond Casting Sand, or Pedro for short, and I'm going to need a lot of him. Petrobond is perfect for casting because it is made of tiny grains of sand mixed with oil, and when compressed the sand sticks together and holds whatever impression you give it. To begin, I gently sprinkle some fine sand over the dagger impressor, and then built up more sand around it. Then, using a mallet, I compress the sand over and around the dagger. After, using a square bit of wood to bash in the sand around the edges of the frame. I repeated this process till the sand reached the top of the frame. Any overflow I scraped away. And then made sure to fill in any imperfections. I later drilled the top of the box onto the frame so that the sand was contained. Using more super glue, I combined the other half of the dagger and used some bricks to hold it in place till the glue had dried. Over the next couple of hours. I then repeated the entire process again, sprinkling baby powder and placing the next frame on top, adding the sand, mashing the sand, and so on. Finally, by drilling the lid onto the frame and then retiring for the night. The next day, I began my morning by complaining about the British weather.
Oh, it's cold.
However, I was eager to see how the mould turned out. This will do nicely. Using my finger, I dug out a cone shape on both halves that would funnel the molten liquid metal into the mould. However, first things first, I needed to work out how much metal I needed. To simplify things, I made a half-scale dagger I could use to conduct a little experiment with. For the experiment, I will need a set of scales, a large bowl, a large container that fits in the bowl, the mini dagger, and a meter strip of aluminium. Yes, the dagger will be made using aluminium. The experiment in question I titled, Working Out How Many Strips of Aluminium I Need to Fill the Mould Using Science, or Waham So Ain't Footmus for short. The first stage of the experiment is to calculate the volume of the mini dagger in milliliters. The first step was measuring the mass of the bowl on the scales, which came out at 299 grams. Next, I placed the vase into the bowl and filled it to the brim with water. Then I submerged the dagger in the water and let it overflow. I then measured the mass of the bowl again with the water and got 326 grams. Now, I subtracted the mass of the bowl from the total mass to get only the mass of the water. Assuming that 1 gram of water is equal to 1 milliliter, I looked it up, then 27 grams of water is the same as 27 milliliters, which works out as the volume of the mini dagger. For the second stage of the experiment, I now needed to work out the volume of the strip of aluminium. The first step was to look at the label for the dimensions. I already know that the length is 1 meter or 1000 millimeters, the width is 23.5 millimeters, and the thickness is 2 millimeters. So the volume, when multiplied together, is 47,000 millimeters cubed. Assuming that 1000 millimeters cubed is equal to 1 milliliter, I looked it up, then 47,000 millimeters cubed is the same as 47 milliliters. So, to answer the question of how many strips of aluminium I need for the mini dagger, I take the volume of the mini dagger and divide it by the volume of the aluminium, and get 0.57 strips, which I then rounded up to just using a whole strip anyway, just to be safe. Knowing this, I made a cast of the mini dagger as a prototype, and it came out great. Finally, by using the calculated volume of the half-scale dagger, I could work out the volume of the full-size dagger by doubling the value in the X, Y, and Z directions, ending up needing 4.6 strips of aluminium to fill the mould, which I then rounded up to 8 strips because I'd rather have too much extra than not enough. With all that boring science stuff out the way, we can now move on to the epic part of the video. Did you know that the melting point of aluminium is around 660 degrees Celsius or 1220 Fahrenheit for the Americans? This Devil Forge can get as hot as over double that, which is terrifying, but awesome. For the sake of safety, and so I don't burn down my garden, I'm keeping a fire extinguisher close by. To turn on the forge, I fully release the propane gas and set the pressure gauge to around 0.04 megapascals, Pedro's ultimate form. And then fearfully ignited the gas. To increase the heat, I turned the air valve until the red flame burst into a roaring blue flame. And then left the forge to get hot, in quotations. Once the aluminium had liquefied, I turned off the gas supply and completely closed all valves before removing the crucible. On top of the molten metal, a layer of impure material called slag had formed, which I removed. Before heating up the metal some more, and consistently poured it into the top of the mold. Any leftover metal I poured into a steel baking tray to reuse for another project. I left the mould and cast to cool down overnight and came back in the morning to check how it went. The casting went really well, apart from this crack that had formed on the handle that made the dagger fragile. In an attempt to save the cast, I used a blowtorch to melt the aluminium enough so that I could weld it back together. But when I picked it up, disaster. My second attempt at me trying to avoid having to remold and recast had me drilling a hole into each end of the handle, big enough for a 4mm steel rod. I then mixed together some 2-part epoxy resin and globbed it onto the steel rod before pressing it into one half of the dagger, letting it dry, globbing on some more and reuniting the second half. I came back to it the next day and the dagger was as strong as ever, but I didn't dare test how strong. With that crisis over with, I could work on cleaning it all up, starting with the extra metal at the hilt. To clean up this part where the metal had leaked up the mould join, I used my rotary tool with a tungsten carbide bit. until the bit became blunt and I had to do the rest by hand, which I won't make you watch. It took a while. I didn't end up sharpening the edges too much, as I was happy with this just being a prop as opposed to a weapon, and I didn't want the police knocking at my door when this video came out. Where the sand had stuck to the details in the plastic dagger, I carefully corrected with my rotary tool. I then used a steel wire brush, which did a fantastic job at cleaning the surface and was very satisfying to do. It almost felt like cheating. To finish the glamorizing of the dagger, I first used some steel wool, which made the surface smooth and somewhat shiny. But as an extra step, I used my rotary tool to apply some polish, and then gave it the best rub of its life, using a sock. Here is how the glamorized side compares to the unglamorized side. At this point, I could get away with saying it was made of steel. Now to add the most important detail of all. Lego Pro 191 is subscribed to my Props tier membership on Patreon. There they get exclusive access to updates regarding my current and future prop builds, on and off camera, and have first dibs on all my released prop templates, discounted and for free. Now their name is immortalized on this prop, and yours can be too. Also on my Patreon is my support tier, where you can take part in polls that decide what I create or play next, with extra, more personal content to view and a community of like-minded people to chat to. Not your cup of tea? Consider becoming a free member to receive upload schedule updates and a sneak peek into when the next video is out and what it's about. Thank you for your support. The final thing to do is to add a wrap to the handle. I made a template on paper after taking dimensions of the handle, which I transferred onto some faux leather fabric. To make this cord, I simply cut out a thin strip using the same leather fabric and used it to cross-stitch the wrap together. With the wrap attached to the dagger in all its glory, that's a wrap. Now it's time for the showcase. Want to help me decide what to make next? My Patreon is now 20% off for new patrons for the next month only. So go ahead and join to vote for what you want to see made next. Thank you for watching. If you made it this far, then you must be enjoying this content. So give us a like, subscribe, and comment the word shiny to let me know that you made it to the end. See you next time.